textbook programming. And after my time at Stanford, I spent a few years in the industry working for JP Morgan Chase. And for last year or so, I have been on my own working on two different NSF grants to explore the feasibility of starting a new initiative on knowledge axiomatization. And that's what I'm here to talk to you about.
Lovely.
Okay, awesome. So we have the recording on. So my apologies again. So
Please go ahead, Vinay.
yes, yeah. So
Y'all can see my slide?
Yes.
Okay. So I'm going to talk to you about this paper that recently appeared in AI Magazine, a community-driven vision for a new knowledge resource for AI. Two members of this group are co-authors, which includes Mike Chinesrath and Gopal Gupta. So guys, please feel free to jump in anytime you feel inspired to pitch in or say anything. The paper was based on a workshop that we ran at AAAI earlier this year, and the workshop was called Translational Institute for Knowledge Axiomatization. This work is being funded by National Science Foundation. So really, I'm grateful and thankful that I got this opportunity to work on this. I'll start off by giving a brief motivation for why we are doing this, then give you a quick taste of the community vision that emerged out of the AAAI workshop, dig a little deep into how we could go about building a knowledge resource today, and tell you about the path forward as to what we are currently doing. The motivation goes back to an old paper that Linnet and Feigenbaum wrote in 1987, which appeared in Niche Guy, that introduced a knowledge principle. So the principle says that anytime a system exhibits intelligent understanding or action, at good level of competence, we can trace it back to a specific piece of knowledge that it is using in performing that action. The knowledge could be in any form: concepts, facts, representation, heuristics, but we are always able to relate the behavior to a piece of knowledge. We know that a version of this principle was operationalized in early expert systems, but expert systems, they showed the knowledge principle only in very narrow domains. And Doug and Ed, they were very interested in massively scaling it up. And they were thinking that if we were to build a large AI system that exhibits broad intelligence, we would need to start with a large body of knowledge, which would be in concepts, facts, methods, models, etc., in that form. And once we have that large body of knowledge, we will use automatic methods like natural language processing and machine learning to continually expand that body of knowledge. And that's how we would be able to operationalize this knowledge principle on a very large scale. The side project that Doug led for most of his active career tried to test this empirically. The project is still active, but its status is in limbo because Doug passed away a couple of years ago. But it's safe to say that we don't have a conclusive answer to whether the knowledge principle is the way to engineer a large AI system. It's also safe to say that over the last 40 years or so, since 1987, a lot of progress has been made in AI. AI systems can do amazing things which were unthinkable a few years ago. And there are other people who have thought about building knowledge resources, most notable of them being Stephen Wolfram. And Wolfram Alpha is also a very interesting system, even though it does not necessarily address common sense or general world knowledge. But it's certainly a leading system in the mathematical knowledge space. Both Psych and Wolfram Alpha, they are restricted intellectual property, so they're not freely available to people. There have been some efforts to build open source systems, which include ConceptNet and Wikidata. They're both interesting systems. They have useful knowledge, but they are not very expressive. So the kind of things that you can say in ConceptNet are very limited, and Wikidata is mostly data, right? It's supporting Wikipedia. A lot of people would think of large language models as knowledge resources, but as we know, they mostly work from text. Some people are starting to add videos and images and other things to the similar kind of system. They are using real world data. They exhibit some common sense. You can, even though the licenses of the leading systems now are restricted, but it's possible that the technology is well known that anybody could build a similar system if they throw enough time and money at it. The biggest problem is that they don't come with formal guarantees. I mean, LLMs clearly have a lot of knowledge, but we don't know under what circumstances are they going to use the knowledge or they won't use the knowledge. And whenever they are exhibiting some performance, we can't tie it back to a specific piece of knowledge that was used to perform that behavior. And that's kind of what the knowledge principle was getting at. And I think LLMs really missed the mark. So the short story is that we still have a critical gap in building AI systems, that we don't have a verifiable source of knowledge that is general purpose that the systems could, AI systems could call upon. So that was the motivation. And we had this 2-day workshop. More than 50 people showed up. The exact count is difficult to get, but the registration list included around 80 people. And one outcome of the workshop could have been that we don't need a knowledge resource. We don't need knowledge infrastructure. LLMs are good enough. And the most interesting thing is that didn't happen. The general feeling and the almost consensus opinion was that it would be great to have a new knowledge resource which is public. Anybody should be able to access. It acts like a infrastructure, just like electricity or water. And clearly, we need some applications to start with. It can't be just abstract. And people thought that robotic planning and fact verification, they would be obvious first applications for this kind of knowledge resource. Even large language models could benefit from this because, already large language models are calling upon limited forms of knowledge graphs like Wikidata. But if a much bigger and more comprehensive knowledge resource was available, generative AI models would benefit from it. And one other thing that was resounding and clear from the workshop was that people wanted this to be very easy to use in the same way as a Python library is. And there's a very nice website or very nice repo of Python library, PyPy. If you're an AI engineer, you can just do pip install this module name, and you can pull and try these modules. And the knowledge resource should provide similar facilities so that it's easy to use by people. People also felt that this needs to be multimodal in nature. It shouldn't be just pure text. It should have images and videos and other forms of representations as provenance. So the text and images and videos, they are not the knowledge resource. There are some people who treat that as knowledge resource, but no, that's not what we are saying. What we are saying is that there is a formal representation of knowledge which has provenance, and that provenance can take the form of text, images, or videos, so that anybody can look at any rule or representation and trace it back to where it came from. Okay. So that was the vision that emerged. And there is a lot more detail to this. We have an 18-page paper, which is in the AI magazine. I'm not going to go through everything, but I just gave you the big picture and the overall taste of what came out of the workshop. In workshop, we had sessions on these 5 topics: foundational knowledge, automated reasoning, evaluation, education, and knowledge curation, because we felt that these were the key dimensions of or key technologies we need to think about as we go about creating this knowledge resource. On this slide, I have captured a very high-level nugget from each session. I'm not planning to go through all of this because there is a lot more detail available in the paper. And of course, we can have the discussion as soon after I finish. But I wanted to say a few words about evaluation. The biggest problem with the evaluation or the way the AI ecosystem works today is it's very hard to explain to a common person what the heck is knowledge and why don't LLMs have knowledge. And so to sort of try to explain that or to get at that problem, I have written an essay which is sort of phrased as, we need a new Turing test to assess AI's real world knowledge. And I was fortunate that I was able to get people at Nature interested in publishing this essay. And the week this essay appeared, it was featured on their homepage. And I captured the screenshot from that day, which I'm showing here. I felt really proud that, oh, wow, I got on the front page of Nature. That's something. But what's the argument I made in this essay? I said, look, we have AIs today which can do really well on, say, law school exams. But lawyers start using these AI systems and they realize, and many lawyers have used it, and they have used the AI output in court filings. And once the errors were detected, these lawyers were fined. So it's a serious matter. It was in New York Times and it was in news all over the place. And I mean, clearly a lot of people like to talk about hallucination, but more importantly, there were statements in those filings in which AI was misrepresenting the principles of law, which is not exactly a hallucination, but it's just wrong answer. And if you just trust this system without actually carefully vetting what's coming out, it's a problem. And at the workshop, we had a gentleman from Educational Testing Services. These are the people who design these standardized tests. And, we asked him, okay, how is it that, AI is doing so well on the standardized exam and it's failing in this manner? And, people at ETS are very thoughtful and they have been working on this for a long time. And they said, look, we have a term for this. It's called proxy failure. Anytime a test fails to measure the exact skills it was designed to test, we call it a proxy failure. And ETS does longitudinal testing over all their standardized exams to ensure their validity. They would track people 5 years, 10 years after they took the test to see whether the test performance is correlating with how well they are performing on the job. So these instruments, they are valid for humans because ETS does this kind of psychometric work. But clearly, these tests are not valid for AIs because we don't have to go very far in the future to see that the test performance of AI is not directly correlated to how well it actually performs on the real world task. So how do we actually address this problem? So at the workshop, there was this idea that was proposed by people that, well, if a human expert interacts with an AI for a long period of time, no strict time limits, you can tell how much knowledge they actually have. And this is kind of how it works with your graduate students, or even when you're on a job, you have a 3-month probation period. And that's how you really figure out how well somebody knows a particular topic or how good they are at a job. The real problem is that that's very expensive to do, and tests are sort of like a proxy which try to approximate having to do a more expensive test. But as a starting point, in this essay, I've argued that we need to have an expert interview style evaluation of an AI system so that an expert can certify that AI does indeed have knowledge of a particular topic. Okay. There are obviously a lot of open questions about how do we operationalize that expert interview, how do we scale it, how do we actually test and score these interviews. Um, Clearly there is a lot more work to be done, but at least at the idea level, this had some traction, and this idea is out there. That and I actually, even after this was published, I got a lot of emails and some comments got published in Nature itself. People commenting on this idea that such an expert interview style evaluation is actually interesting and needed. So in addition to this particular essay in Nature, I have written a few other essays which get at different aspects of creating this knowledge resource. I have an essay on how do you evaluate the reasoning, how do we apply this kind of approach to different domains like education or law. I've also been trying to articulate this high level vision of why knowledge is important. Should we be just worrying about bigger models, or should we be worrying about capturing meaning in computers? Should we be just teaching computer patterns, or should we also be teaching it concepts? So, and these essays, they are all meant for non-AI people, because a lot of money is being invested by folks who really don't know AI. They really are going by the promise of AI. And so we have to be able to explain to them why is a knowledge-driven or a system based on knowledge principle is different from what we keep seeing in the mainstream press. And we have to be able to articulate in a manner that is accessible. And that's what I've been trying to do through these essays. These 6 are already out there. They have had some traction, and I have a few other essays which are in the pipeline and I'm working on, and you'll hear about them once they get out. So as a path forward from the workshop, NSF invited us to send NSF asked us this question, that based on the workshop, what is one thing you would do? And we said, well, there needs to be a proof of concept that this kind of knowledge resource can actually make a difference in the current climate of AI. And there was a gentleman at the workshop from Bosch who came forward and he said, look, we have some use cases. We can give you some use cases, and let's pick up some off-the-shelf KR tools, and let's try to show that using a KR or a knowledge representation would actually would improve the performance. And these 3 use cases are listed here. They are trying to leverage on the work that has been done in KR on spatial reasoning, on representing action, and causal reasoning, and are aimed at showing that by leveraging knowledge, we can perform better on these tasks. This project just got funded, so we don't have much results to report on this, but I put it out there just to give you a sense for how we are thinking of operationalizing this vision that resulted from the AAAI workshop into an actual concrete program that might make a difference. So in addition to this POC project, we are doing 3 other workshops, one in education, one on law, and one on supply chain. And the goal of these workshops is, again, to continue to do community building, to bring in stakeholders who are interested in solving particular problems that can benefit from the use of knowledge and knowledge representation. And we already had the workshop on knowledge graphs for education. There were folks there from places like Gates Foundation and Renaissance Philanthropy, and there is a big research program which is jointly put out by different foundations, which is in the education space, and we are talking to them to see if they are willing and interested to bite a piece of this problem and take it forward. And I'm hoping that once we do the remaining two workshops, we'll be able to find similar stakeholders. The workshop on computational law, this is being jointly done with Mike Janesrath here, and he has been brilliantly secured a space at the National Academy of Sciences. Clearly, the venue is prestigious, and we are hoping that the outcome will also be proportionate to that. That's pretty much what I wanted to say, and this is my concluding slide. And we can use this rest of the time for discussion. And these are the prompts I had for the discussion. How do we engage logic programming community in building this knowledge resource? How can we co-design this knowledge resource? How can we co-create this? And with that, I'll thank you, and let's have a great discussion.
Thank you very much, Vinay. It's a very interesting challenge.
Thank you.
Do we have any questions for Vinay?
So just a comment I would like to make at that is that, whatever knowledge representation methodology we come up with, it has to be simple so that, pretty much anyone can represent knowledge and correctly and not have to spend a lot of time ensuring that it is correct. So a lot of tool support and all those kind of things would be there. And I guess the DARPA CODOT project, in some sense, right? That's what the goal is to reduce the time it takes for a knowledge engineer to represent knowledge for certain task.
As nobody's asking a question, I do have a little comment. Maybe my scientific obsession. We're so intent upon measuring AI and focusing on prestigious notions like intelligence. And companies are making lots of money from this prestige attributed to computers. Based on a
with the audio, Veronica.
I think your audio is hard to hear, Veronica. We can't hear you.
Hey, I changed the settings today, and
Right. Yeah, that's right.
It seemed to be working, but okay. Yeah, I kind of I'm dreaming of a different test for AI, which is, why don't we measure AI's helpfulness to humanity in a time where we're suffering so many threats to our very existence and that of the world. It seems such a niche little luxury thing to be working on, trying to measure whether and how and what kind of intelligence machines have. Now, this is not a critique of what you're doing, Vinay, because I think what you're doing is extremely useful, focusing on knowledge. But regarding the first part, the Turing test, I think we need a more humanity-oriented.
So I did actually deal with that in the essay. And the way I think about that is that we can obviously measure AI on specific tasks. So we have some people at Stanford who have developed a medical evaluation benchmark. They call it MedHelp. They have a list of 155 tasks that clinicians have to perform that AI could help with. Okay, and they have a very beautiful diagram which shows that, well, AI does really well on these tasks and it doesn't do well on the other tasks. And I think what we are saying is that's not the point, because of course, that's how expert systems work. We could optimize the hell out of them on a particular task, and sure, now we have a system that we can optimize the hell out of on 50 tasks. But that's not the point. Point
Exactly.
is the system using knowledge? And does it have general purpose knowledge that it can use not for just one task, but can it use it for any task? That's really what we are after. And obviously, if it had the general purpose knowledge that it can use for any task, it will have humanitarian benefits. Of course it will.
Or if had specialized tasks, the aim should be to impress somebody by attributing human intelligence to a machine. I mean, that's a stupid aim. The aim should be to help humanity. Whether it's
It's just, if I can, it reminds me of this morning I saw in the Funny Times a little blurb, and I don't remember all of it, but the thing I do remember is that, yeah, AI is really helping me. Now I'm going to be able to ride in an automated car to a job that AI is, a job that I used to have that AI is doing for me.
yeah,
I think this is a question that can be asked of any technology, and we are concentrating on AI because it's so
absolutely.
prominent now. But the truth, we
but
need to figure that about anything.
that is true. But AI is so specific about fooling people. It's from the beginning. Let's fool somebody to think that they're interacting with a human. And now let's fool people out of their jobs because we'll pretend that AIs are replacing them when they don't really pay benefits
Well,
or taxes or anything. It's all about impersonating and fooling.
but I think the way I would frame the discussion is that what role should logic programming have in AI? And
That
how can logic programming communities create libraries of knowledge that could be plugged into AI?
My question is, what's the representation, what's the knowledge representation framework or frameworks? I mean, the Code project has sort of chosen this Ergo AI language as the way that knowledge is represented in some formal way. And that's interesting. It's a pretty general language, but it's clearly limited. I mean, any single language is going to be limited, right? And I'm wondering how, I mean, and psych, took first order logic essentially, right? But there are a lot of other ways of representing knowledge, and how are they, and I assume you want all of them, or many of them, I mean, maybe not all, but many of them. And then they all have to be integrated in some way, or maybe not integrated, but communicating. I mean, if you have knowledge in different forms, you need to be able to put it together. Anyway, those are the kinds of questions I find interesting.
So we had a lot of discussion on that at the workshop as to, okay, what about the KR language? Right? And
So what did they find? What did they choose? What were the conclusions?
so the general feeling was that it's not really about the language, but what you can do with it. And
But what you can do with it depends on the language, right? I mean,
well, so
you need to have a form. The
so,
whole idea.
so let me argue it slightly differently. And people, on one hand, the KR people feel very jealous and left out and sometimes angry and upset at deep learning and ML. But we can also reframe that. Okay, what is it that we can learn from that community? What are some nice and interesting lessons that we can take from what they did um, that KR people could adopt? And one of them, which could be a little bit controversial, maybe it is controversial, is while in the NLP and ML community there was this thing that they built called Hugging Face, and the main idea about Hugging Face was that you could go and put your model out there. You could put your name entity recognition model, your translation model, your relation extraction model, and anybody could go to the website. They could upload their data, and they could apply that model against that data and see what it does. And if they like what it does, they can download the model using simple pip install, and they could improve their application. And they just made it really simple. In the Hugging Face, again, they were working with two different models. There was a TensorFlow model from Google, and there was a PyTorch library from Meta. And
Vinay, your audio keeps going in and out.
I hope it's
Maybe you can speak
internet.
louder.
Yeah, it's probably my internet. And they provided translation between the two. Okay, and so and people who were using the Hugging Face portal, they didn't have to worry about the translation. The portal would take care of it. You could upload your model in the TensorFlow format, and it will automatically convert it into.
But then you're sort of repeating the expert system kind of a framework, because you have a particular, a particular domain or particular representation that applies well to certain domains, and you never integrate that knowledge, or what if you want that knowledge to be processed by another one? That's the same kind of knowledge. That's why it's going to be duplicating the knowledge.
No. I didn't convey my point clearly.
I'm sorry.
The point I want to convey is, what is it that KR community can learn from that? Okay. If, say, we were to just copy that idea, and so that's again purely an engineering thing. It's not like fundamental breakthrough.
So if I can just, sorry, no, go ahead, finish, and then I'll make a comment.
No, I'll let you finish.
Yeah, so now I was just going to say that, see, this machine learning community and, or maybe even an NLP community, I mean, they have an advantage in the sense that the correctness is not guaranteed. So you give it any problem, it may give you 10% accuracy, 5% accuracy, or 90% accuracy. But it does something. With KR tools, if something is off, it doesn't work. You see, there is no graceful failure. So that will turn off people, mightily, that it's either 1 or 0. You see my point? So I guess we have to build KR tools, and that's maybe what I was saying in the beginning, that will fail gracefully. And I think until we do that,
well, actually, they can fail gracefully, at least in the natural language processing domain. We know logic grammars that fail if the sentence is wrong and don't tell you anything else. But if you apply linguistic theory, like property grammars, then instead of getting, as a result of the analysis, a parsed tree or a no, you get a list of satisfied properties and a list of...
So those are the kind of things I think the KR tools have to do. And then, or maybe even help that, look, this is not going to give not produce an answer because of this. And then, you have some pathway to improving things.
But it's not an improvement. It's a good thing to say this failed because of that. It's not a failure of the analysis. It's a failure of the sentence to be correct. So the analyzer detects correctly that there's a failure, but instead of just failing and not telling you why, it says this sentence is incorrect because this, that, and the other. That's a success of the analyzer.
Right. But I'm not sure if that's always there. That's what I'm saying.
The
explanation why it failed is not always provided.
Yes, it is. In property grammars, it is.
In property grammars, but other things, other tools.
I'm saying that just like we've done it in computational linguistics, we can also do it in other domains. It'll be other ways of doing it, of course.
Right. So let's do it.
Doesn't mean that. What I'm saying is, just because you're using knowledge representation, our tools, doesn't mean that you're going to irremissibly fail and not know why.
Right. I'm saying that that's a challenge for us, and we need to make our tools better. That's all I'm saying.
Okay.
So Mike has his hand up. So
Mike. Yeah.
Well, I just wanted to comment that some of my conversations with the folks at the workshop suggested that we would not prematurely select one representation for all knowledge, but rather that the knowledge resource would support multiple representation languages. So, logic programming obviously had a seat at the table because some of us there are hardcore enthusiasts for LP. So that would be there. But there were others who would say over my dead body, and we let them try theirs as well. The question is, do we have n representations if there are n people, or do we just have a small number? And I think the sense that some of us had, the optimists had, was, let's try a small number and see what happens. In the early days of electrification, Tesla said we're going to have direct current, and Edison said no, alternating current, and the two of them ran in parallel for a while, and eventually alternating current won out, at least here in I think probably most places in the world. And so yeah, so we should try a few different representations and let's see what happens. And somebody will do well, or maybe they'll continue to have multiples, and that will be good. But the other point, so that's point one. Point two that I wanted to make was that there's a difference between the representational formalism, which is what I was addressing and what I think mostly we've been talking about, but also the ontology or the representation within those formalisms. So even within LP, one can represent the same information in many different ways. And that's a more fundamental problem. We have to deal with the intertranslation of those or the interoperation of those. Yes, that's always going to be the case, but that's one thing. And then on the other side, there's the arguments about what formalism we're using. And I think we need to tease those two apart because many of the arguments one has really has to do with conceptual formulation rather than with a formalism, and you can deal with multiple formalisms without solving the problem of representations. Anyway, sorry.
Okay, so thanks, Michael, for that. I think you captured the discussions really well. But let me just I've been able to collect my thoughts about what can we learn from Hugging Face. So if I were to interpret that as a task, okay, what can I learn from there? Let me pick a concrete example representing actions. Okay. Gopal is going to want to use CASP for doing his actions. And if I go to Michael Gelfond, he would want to use Elm. Okay. And I'm not going to ask either of them to change what they're going to do. Instead, Gopal can do it in CASP. Gelfond can do it in Elm. They build a library of actions. They bundle it up with their reasoner. And now I'm a robotics guy. I need to access this library. I would make API calls to Gopal's library and to Gelfond's library and see which one is better for me. Right? I don't have to worry and bother what is inside the black box. What language, as a robotic guy, I couldn't care less. I'm interested in improving my robotic application. And from whichever place I can get the appropriate knowledge, which helps me, I will use it. The problem that we currently have in the KR community is right now, the number of places I can get such knowledge is 0. It just doesn't exist. And that's what we need to change. Bob? Bob has his hand up.
Right. Isn't there a neutral format, an interchange format, already available for all of these different knowledge representation formalisms, namely unambiguous natural language? In what sense is unambiguous natural language not an adequate general purpose unifying knowledge representation? What's missing? What's lacking? If you read behind
my response is that if it's unambiguous, it's not natural.
Come on. That's not a.
Agree with that because one of the main functions of language is economic expressivity, and it is achieved in partly through deliberate ambiguity, which is exploited in many creations, human creations like poetry and literature and lots of things.
But that's not true for no formalism that I know deliberately incorporates ambiguity for whatever purpose.
Every unambiguous natural language that I know of has a target translation that it translates to, right? Logic programming, first order logic. It has, so it's really just syntactic sugar for some more some underlying formalism that, is
and the
we know
meaning
of.
that
And as a matter of fact, the fact that it's unambiguous depends on the fact that it translates to the background into in an unambiguous way. So I think, I think that's not particularly helpful to think about that way. But I may be.
I think I agree with David because it's the knowledge that you're interested in that and the representation that comes out, and that can actually might make a huge difference in okay, maybe we don't care about efficiency, what we're interested in, and one can find examples. I not off the top of my head, but I can send some examples.
I'm afraid I stand by my claim that put it this way. Let's suppose we have many different representation languages. Isn't there going to be a way of making the knowledge expressed in those formalisms available to ordinary people? And isn't that going to be through language? And if those representations are unambiguous, then won't the resulting natural language also be unambiguous? In which case we could have started there in the first place and not argue about what representation we're going to use. We just express ourselves in an unambiguous form. Now, Veronica's point is not a point, I don't think, about ambiguity. It's about what we call open texture or vagueness, which is often confused with ambiguity. I mean, we want to be able to have concepts which are not precisely formally defined and which can be interpreted in a variety of different ways. They're at the bottom of the hierarchy.
As an example, a probabilistic logic language might be useful. How is that translated to natural language? That has more information, quite a bit more information than natural language has. How would you, turn a richer than first order logic language into natural language? I'm not sure it would be all that natural for people, to tell you the truth.
Well, this is
so I think the first rule we had, one of the outcomes of the TICA of the workshop was we will not argue over representation language. We can, I love to, but again, the point is not about which language, but point is what you do with the language and how do we make it other people to make use of the knowledge expressed in the language. I think
So
that's
you assume that you will be able always to translate one to the other, I guess. That's what I mean. Isn't that the only way to have all different possibilities available? That we can go from one to the other?
Well, I think as Mike mentioned, we can always start with a small number. That's fine. But that again is not the point. The point is who is going to write the knowledge and who is going to make that knowledge.
So, sorry, I had my hand raised long ago. I just want to say, well, first of all, a comment to the authors of this work in the workshop. I'm very grateful to you all because you all include this license column in the evaluation of the possibilities. And that's an important one to make the knowledge available to everybody about the fact that some IPI are relaxed enough to allow for everybody to take, participate somehow in the distribution of, in the use even of the knowledge that is being collected. That's very important. Thank you for that. But I wanted to ask you something. You were prepared to consider LLMs one of the knowledge representations, I understand. So you are accepting that they are actually modeling, they are called something.
Yeah, so there was a column
right?
There was a column about formal guarantees.
Exactly. That was just one out of what five features that they don't fit. That the only problem they have is that their output is not guaranteed because we ask a question and we repeat the question that they provide a different answer. But that's because of this stochastic nature, right?
No, so that's not the only column that is of importance. The other one was the first column, the knowledge is all in text.
Yeah,
So
but as you said, that's also changing now.
so again, I think there's another essay I'm working on to sort of explain that. And the argument I make in that one is that, sure, LLMs have some knowledge, but among the billion parameters that it has, we can't point to where is it storing a particular fact or a particular rule or particular constraint. We can't tell that, right? So it does have knowledge, but it's not the kind of knowledge that they were talking about in the knowledge principle.
So I would say that let's set a goal for ourselves. Maybe choose a specific problem, like, you said the Bosch robot or something. And then, let's build a knowledge library so that we could reason in that domain, represent knowledge in that domain, reason in that domain. So maybe that's a challenge we need to create for ourselves, or the community, the TICA community. I mean, something simple that, is given as a goal. And so any thoughts on that?
I love that idea, and I love to see that happen. So Gopal and I have already talked about that, and I've shared with him a library of actions, and I've done the same thing with Daniela, who will use Galfond's Elm language, and Son Tran is also going to work on that. So we already have 3 takers of that problem, and if we got 3 separate action libraries to represent those actions, we can test it with the Bosch robot and see which of them is most useful.
But which one's better is going to depend on not the knowledge representation framework, as Michael said, but the knowledge in the representation framework. So it's not going to be any kind of a test of the knowledge language, or a minimal test, I would say, of the knowledge language. It's going to be a test of what knowledge, how well the knowledge was encoded in that framework, which is fine. It's just that, again, that doesn't help us. I'd go back to Jacinto's point, is that what I think is important, needs to be thought about, is translations among these frameworks.
That's fair. That's fair. But I think if the higher level goal was, let's build action libraries in few different LP languages, if that was the high level goal, translation could be part of the activity of that. And if we can get the community to sign up to that, that'd be amazing. I mean, at least, we have something concrete we are chasing after.
Bob?
I'm a bit worried that this knowledge will be unintelligible to humans. I mean, if this knowledge cannot be expressed in language, if the knowledge cannot be expressed in natural language, then is it knowledge? I mean, if you're going to use numbers, tensors or what have you, and call it knowledge, is it of any use? I mean, if it leaves humans out of the loop, if humans can't know, if a machine can know, but humans aren't allowed to know because the formalism hides the knowledge and keeps it to itself and uses it in ways that we can, benefit from, but we can't understand because the knowledge can't be expressed in natural language. And if it can be expressed in natural language, it'll have to be unambiguous. So why don't we start with unambiguous natural language and let people translate that into any, more precise, more symbolic, more machine-oriented formalism that they like. So,
there are reasons for this, Bob. And one of the reasons for this is that in certain areas, it's desirable to have more formal languages because they're more perspicuous, less verbose, and so forth. If you pick up a textbook on structural engineering, you'll find a lot of formulas in there that human practitioners find useful. And if you were to take that textbook and translate it entirely into natural language, so all the formulas disappear, it would grow very large. And I have a suspicion that the utility of that material would be diminished because that representation isn't as perspicuous. I don't disagree that we should be able to translate into natural language so that people can be explained. I'm not sure you've made an argument that all human knowledge must be represented that way at its base, although that's an interesting prospect that we should be considering. Anyway, I do think there are reasons for that humans do find useful. It's not just that machines find useful, not just a big tree of weights. It is still useful knowledge. It's just not necessarily in the syntax of natural language. And there's other dangers we can talk about. There was one other thing I wanted to point out, though, that came up in the workshop, and I remember Leora Morgenstern was her breaking egg. How do you represent how to break an egg? Or I can't remember the exact details of that. So that's tough. And the question that came up was, can we represent that at all? And so a lot of discussion, 45 minutes of discussion got devoted to whether certain aspects of the world can be represented, which is an researcher-oriented view of what the utility of such a knowledge resource would be. And I found that fascinating, but frustrating. Fascinating because those are really interesting questions, and I'm a researcher, but frustrating because I think one of the ideas was of the effort, TICA effort, the National Knowledge Resource, International Knowledge Resource effort, was to see, can we write down the knowledge that we know how to represent in a way that everybody can now use? So we're not trying to solve the problem of representing all knowledge this way, but can we usefully put this all into a knowledge library that people can draw upon? And it's not just for researchers to do more research and publish more papers, but also for people to do useful things for the world, as well as the people doing research. And I think there was a lot of discussion about whether you can represent knowledge versus can we do it in a way that other people can use usefully. And so whether, maybe that's natural language, maybe it's LP, I don't know what the language is, but it'd be really useful to just write down stuff. I like to have one place to go to find a representation of information about kinship, fathers, mothers, grandparents, or robotic actions or whatever. I'd like to have one or place where I can go and collect the best representations that are available today.
Yes, I agree. Thank you for the comment, Michael. I would like to make a meta comment or a meta question. Maybe we should be working as AIers with law enforcement people, lawmaking people, in collaboration with the legal structures, because developing a public knowledge infrastructure, that's great. Is it really going to be public? Everything is being captured. Everything that used to be public is being captured for private benefit. And they're using collective creations, collective work to pretend they're replacing us. And yes, the public knowledge infrastructure is going to be great for the public, but is it going to charge big AI for its use? Because where else are we going to get, our government's going to get money from if they're taxing only labor, and it's disappearing thanks to AI? We're creating more and more facilities for big AI to capture, transform in money, rid us of all our jobs, distribute the remaining work as unpaid work among the population. And are we going to continue only looking at the scientific, very interesting, wonderful, I love it too, point of view, but shouldn't we be advancing at the same time as we're consulting how our advances are not going to be turned against us?
Yeah, I mean, I think that's a fair governance question. It's certainly not a technical question. It's not a it's a governance question. Somebody has to worry about it.
Should we be involved in working with governance? Or should we just blindly go ahead and let our results be used as they will, against or for the people?
Actually, knowledge representation or, knowledge-based approach could be the answer where, one could actually do an assessment and, if you use some knowledge-based tool for some some task, then perhaps an analysis about governance can be put out as well, saying, how it can have, which can be, I guess, done with a knowledge-based approach, but maybe much harder with just a machine learning or, these generative AI-based approach. So yeah, that
we have tools, and I agree, we have the tools to help law enforcers, but maybe we should be working already with people that are interested in turning AI for good, for use of
there should be an output saying, do you really want to do this? With everything. It may not be good for you. Button.
Yeah, I guess the first thing is to decide whether we should go this route, and then how, if we do decide. But I think it's important to decide.
But I mean, should it naturally fall out? Because, that's just another property of the system and that you can then query,
It
right?
has naturally followed. For instance, when all the information in books that was created with public funds and public effort was inserted into computers, all the benefit is, most of the benefit is, financially at least, is being funneled into the big AI companies that control the results of technology that was produced with public funds more than anything. Researchers, teachers. And we don't see the results of that, but we see even worse, we see bad results. Like some of the tools are being used for very bad things and have very bad consequences, maybe unintended, like for instance, biases got through big AI because of the quality of the data, which is not checked at all and it's not even verifiable. So maybe unintended, but intended or not intended, we should be able to reorient an effort that is public and is using basically the knowledge of entire generations and the technologies that have been publicly developed for mostly private, enormous benefit. And at the same time, that benefit is resting on the miserization of most people, because we're losing all the jobs. And we're being told that we have better things than the people working there, but it's not true. Even in simple things like an answering machine, it's your time these machines are using to get rid of the people that did a wonderful job and are, to me, are essential workers. When I need to ask a question about a flight and I don't get an answer to a machine, it's an essential worker that lost their job. And I'm being run through all these menus for half an hour of no results because the essential worker is gone. So are we going to continue building tools that we leave to whatever use for or against humanity will appear there because of who is controlling the AI industry? Or are we going to try and work with legislators and try to turn our efforts and those of the previous generations to benefit of our and future generations?
So, Veronica, I'm just curious here what your thinking is about, attitude is about this. So I think these are really fascinating questions you're raising, and important questions are also fascinating. Well, important questions you're raising, and we should be studying them. There's a suggestion, however, maybe that you're making that I'm a little bit more disturbed by, which is that we should hold off on doing work on this until we have answered your questions. And that's disturbing. I think we should be doing those in parallel, personally. We should be moving forward to try to develop the technology. At the same time, we're studying, is this the right technology? How can we solve these governance problems and so forth? And I wouldn't want to put on the critical path the answer to the questions you're raising, because then those don't have easy answers. It's going to be a long time before we can answer them, and we won't know what the options are until we actually explore some of the technologies and see what's possible. So I mean, I'm saying I think what you're saying is very important. We should be doing that. And in fact, we talked about that to some extent in the formulation of this knowledge axiomatization effort, that we should be looking at this as a parallel path of discussion, of analysis. But are you serializing or are you parallelizing? I'm just not sure how you feel about this.
I think it depends. I think where things are not yet very, very clear, it's understandable to go in parallel, but we should still have some kind of equivalent of a Hippocratic sermon, which we don't have for AI or for anything but medicine. We don't have it. I don't know how to go about it. I'm not suggesting anything in particular about it because I don't know, but precisely that's why we probably should be working with legislators. And then there are some things for which it's very clear. Like if you're working on an application like denude, made for denuding female dressed pictures of women or girls, and maybe that should be legislated out. That's a clear damaging application of AI. And it's out there, it's being sold like nothing, no problem. So it depends. If something is really clear, we should be right away saying, no, I'm not getting involved, and I want to get involved with legislators to bar this from happening. If you have an application to kill everything that moves with an utmost efficiency, children, animals, etc., well, that should not be worked on, I think. But if we don't know where these public knowledge repositories of knowledge are going to, and we're providing a general tool that's going to be used for good things, and we still don't know what bad things will come out of it, we could do it in parallel. Or we could say, for instance, making a statement of intention, saying in our papers, it is the intention of the author this never be used for ill purposes, however you want to define it in your particular paper. I think we should be very conscious of this, because it is unconsciousness of this that has led us to a point where we are. And whether we do it in parallel or in anticipation or a posteriori may be a function of our own application, what it is we're doing, of our individuality and individual thinking, because we're still not under a Hippocratic oath of any kind. But we may be thinking of developing one. I know there's many things we have in our to-do list, but I think this is an umbrella that we should keep in mind at the very least.
Certainly. Yeah, definitely interesting idea. Yes, I agree.
Yes, absolutely.
Thank you for listening.
It will also be part of the conditions that we set on our licenses. For instance, we say this is not
Sorry,
allowed.
I can't hear, Gopal.
It could be part of the conditions that we set in our license, for instance, where, the conditions and our author is able to set up the way his or her work is used eventually, and that those could be there. We could think.
I think, Jacinto, your voice is not properly audible.
Sorry. So now I just wanted to agree with Veronica, but that could be part of this legal framework that we have to think about with licenses and things like that.
I think it would be great to find some group of legal helpers that we could interact with.
Yeah, but still, we must be ready to do the hackathon in the way that we were saying before. That we have to attempt to create this. First of all, these various representations and ways to relate between them, which have to include LLMs, of course. We have to extract from them something and to make sure what they are, if they really contain knowledge, because they are good. I mean, we cannot deny that they do a job. I mean,
absolutely, yes.
We cannot deny that, and they do a job in natural language. So it's not a simple thing.
Mm-hmm. Well, it being 9:12, maybe we'll call it a day. Does anybody have any suggestion or final thought or anything else to add? If not, we'll thank Vinay for a very lovely talk. Thank you very much. And I hope to see you in future talks too. So in 2 weeks, we're meeting on Tuesday at 9 a.m. You'll get the reminder. Have a lovely 2 weeks.
Yes, thank you, Vinay. And I think the work you're doing is great. I think you keep focus on knowledge representation. So that's really awesome. Yeah.
Certainly needed, and for the public too. badly.
Yes, appreciate that. And you're getting the articles out in these public forums like Nature and Scientific American. I think that's wonderful.
That's super.
Brilliant. Thank you.
All right, folks, then we'll see you in 2 weeks.
Okay. Bye-bye.
Bye.
Bye. Bye.